Hello. So now we are going to discuss about quality of service and service level agreement. These things are being used and being involved with monitoring, resource management, and resource provisioning. So we are going to discuss about these topics. First of all, quality of service. That service quality and performances measurement were there since telephonic systems. Means whenever there is a telephone, how better you can receive a call, how better you can discuss with a person. Then there's a computer network, that how better a computer network is working. So there's a computer network also have some performances, that what is the availability, what is the response time, all these things means packet, how packets are being transferred. Thereafter in cloud computing also, that the thing that we are discussing, there's also performance service analysis are there. Then user of networks are also have to have the quality of service analysis, that whatever be the client and their network, so they must have some analysis over the quality of service. Thereafter it could be, what I want we want to say, it's majorly quantitative analysis. Quantitative analysis means in the network services, this is the most basic thing uh, which were there in the cloud computing of networking, means how the network services are working, that what's the packet loss, what's the bit rate, what's the throughput, transmission delay, availability jitter. These are the fundamental computer networks quality of service, which can be measured with the quantitative analysis. Then service level agreement, that there's a contract between service provider and service consumer. So there's a quality that has to be managed and maintained. Is availability. That availability has to be, what's the availability of that cloud service, whether it's available 100% or not. Then there's responsibility, how much responsibility is being taken by the uh, cloud provider. Then there are different level of service level agreement. So these are the level which are written as fundamental. Customer based service level agreement, where an individual consumer group actually signs a contract with the service provider. Then service based SLA. So the service based SLA is when all the consumer using the service are jointly sign the contract with the service provider. Then multi-level service level agreement, multi-level SLA, where different set of consumer for similar services, means different set of consumer, different types of consumers are there, and there are some similar kind of services which were working. So means you can have different type of services working, and you have different set of consumers which are using. So in this there is a corporate level SLA, means some institute or organization have a generic service level agreement or service level management being discussed with the some cloud provider like Google, Facebook, etc., or LinkedIn, Microsoft. Then customer level SLA, where all the service level management issues of particular consumer group. So what is particular consumer group? Means there's admin, there's a type of uh, clients are there. So there are various type of groups that could be possible, and there could be like one department could be of medical, one department could be of engineering, one department could be of management, one department could be of IT organizations. So IT organizations are also different from this management and engineering. So they have their particular agreement with the service provider. Thereafter, service level agreement, where this service level management issues are relevant to specific services, means like Google Docs, a specific service, like Google Slides, a specific service. So these are specific service and these are being managed and operated. Then you have service level agreement for web services. So web service level agreement that it says means how web services could be monitored, all these things. So basically, what are the parameters or the metrics that on service level agreement contract has been signed? So QoS parameter, quality of service parameter, SLA negotiation, SLA monitoring, SLA violations are there, and there are SLA enforcement. There are various type of SLA could be measured. Then the performance metrics, which were very fundamental to computer networks or service performance metrics, are like turnaround time, means how the turnaround time to complete a certain task. What is total resolution time, total time to taken to complete a certain task. Then MTTR, mean time to recovery, that time taken to recover after an outage of service. So mean time to recovery is how much time it will take after some service has been failed. Then uptime, network uptime, power uptime is there. So how much time it takes to restart the uh, network, how much time it will take to restart the power. Then public cloud service can be used in the three cloud provisioning. So the three cloud provisioning are like consumer self provisioning, advanced provisioning, dynamic provisioning, provisioning and orchestration. So in the first one, that how public cloud could be managed is like consumer self provisioning, where consumer makes a contract and pay as per the usage to the cloud provider and directly to the cloud provider. For example, institute is operating with Google or Microsoft domain like email, form or docs file is being operated. Then advanced provisioning could be there. Like what are the advanced provisioning? Like consumer have a contract and pay in advance to the resources. So there's a consumer who is making a contract and pay in advance for the resources whatever they are using. So it is advanced provisioning. You get the advanced system installed or enabled or produced. For example, in case of online event management, so there's an online event management company which actually hosts the good interactive website, and you can connect with that website. So that's online interactive website for doing the advanced provisioning. So the consumer have to pay in advance for that online event management. So event could be of only 3 hours or 3 day, but for that company have to make uh, website earlier. Then dynamic provisioning means provider allocates resources as per the consumer uses. Then deprovisioning when the resources are not in the use. So what happens in some of the cases there is sudden increase in number of customers. So in that case, cus- service provider have to allocate more resources, and then there's possibility that some of the users are not using the resources at present. So these users are not in the usage at present. So that needs deprovisioning. What is deprovisioning? Means resources should be freed so that free resources could not be charged based upon the consumer usage. So whenever consumer use, there's no large number of resources being used. So for those large number only, uh, consumer need to pay. Then provisioning and orchestration. What is provisioning? So you need to create your own cloud, you need to modify your own cloud according to your documentation. You need to delete some resources if you want, and you have to maintain orchestration workflow and manage the workload. Means you have to do resource management and provisioning by yourself. Means you are the owner of that whole cloud computing stack. So we'll discuss elasticity and resource provisioning. What is elasticity? Elasticity is provisioning and deprovisioning of resources in automatic manner. What we discussed just now, provisioning is adding on the resources and using on the resources. Then deprovisioning means the free resources could be separated out, and that free resource could be used for some other purpose. So that is deprovisioning of resources, and these all things need to be automated. Then there's two things that we need to avoid in elasticity. So what are the two things that we need to avoid in the elasticity? One is over provisioning. What is over provisioning? It means that you have allocated more resources than it is required. So there is more resources which were idle and which were not in the usage, but still you had given sufficient resources, but these are not being used. So the issue is that consumer or customer need not to pay for useless resources. These idle resources, if that customer is paying for these idle resources, it's not good. That is over provisioning. Now we'll discuss under provisioning. Under provisioning is means allocating fewer resources than it is required. So what happens? There's a large number of customer or client is coming, and these customer are facing some availability or some response time issues, some delays there. So this is also need to be avoided. Then the issue with this is like poor service performance. So slow and unreachable things are there. Then this will lose customer, number of clients may be reduced in future because they are suffering with performance issues. So there's example like slow or unreachable network. So this is an example of under provisioning. Under provisioning and over provisioning should need to be avoided. Thereafter, monitoring. So how you can monitor? You can monitor RESTful web service or SOAP UI APIs. Then you can monitor micro services and different type of APIs that are exposed in web. So you can measure the internal application and do the analysis of whatever been new happening to that web service. Then monitoring internal APIs, this is the another thing. Monitoring online APIs another thing, and monitoring internal APIs another thing. So the customer you can monitor, the private network you can monitor, local network available you can monitor, data center you can monitor, private cloud you can monitor. For monitoring, there's automated code being written for all these things. How these five different things are working: customer, private network, local network, data center, and private code. So these automated code you or script you have to manage for monitoring. So monitoring API throughout the life cycle. So it's necessary for engineer to monitor a particular API or web services throughout the life cycle to find out where is the defect and what are the issues that could be resolved as soon as possible. Then aiding some continuous development. So if there is new features being developed, so the how this new feature is working. So these are also need to be monitored. Then deployment happens whenever new features are there. So whether that deployment is okay or not. Then IT operations are going on. So suppose new servers are being added, whether these servers are being uh, working properly or not in the cluster. So these type of things are being monitored throughout the life cycle. So now this is a framework for SOAP UI monitoring. This is an example, good example. Like you have toolbar in the one. So this HTTP proxy port number 8081 is being monitored. So overall control of SOAP UI is in this framework. How you can monitor some coverage tab. So it's like place where you can check coverage. So just how much coverage it is. Then traffic log tab toolbar. These are the number of customer they are accessing the website. So what is the response time and all these things are there. Then filter bar is there. So filter bar is over here that uh, which operation you want to monitor. So if you can choose one operation out of it, you can have different type of request host, target host, interface. Then traffic load logs, how the traffic logs is there. This the whole thing that uh, time taken or these response request response time. Then request tab, request panel. This is a request body. So body is there. You have to send these values like for a currency conversion, this ZDU is being converted to Australian dollars. So this is getting the response like conversion rate is 0.015. So in the response time, seventh one. So this is how you send the request. It will go to the website and response will come to you. Then there's advantage of monitoring. What are the advantage? It is useful task. Basically, it prevents failure at earlier by replacing as soon as possible whatever been uh, problem is there. Means if there's unavailability and problem and there's some issues happening, so that issues can be resolved as soon as possible. Then verification of service invocation, that whether that service is proper or not, that pre and post condition are being met or not. Means there should be some prerequisite that for a service invocation there should be post condition whatever is happening afterward. Then there's triggering of recovery action. Means whether that uh, mm, whether that service is being properly working or not, how you can recover the some action that you needed. Then this QoS and SLA. What is uh, similarity? Means what is the relationship between this QoS and SLA? So QoS is the for a service can vary over time and quality of service need to be monitored. So QoS vary over time. But SLA needs testing and guarantee, means it remains fixed for large amount of time. And this is a contract. SLA, service level agreement, is a kind of contract between client and provider. Then different stakeholder test individual service or service centric system to ensure the or verify SLA. So in maintaining the SLA, you need to do the testing of individual service or a whole system for assuring that different stakeholders are getting good performance. Then testing levels are there. Whether that functional testing is required, means some operation input output you need to test. Non-functional testing means what's the response time, what how whether it's available full time or not. Then there's integration, means four different operations are there. Whether these integratedly calling one to one another is getting you the response perfectly with correct answer. Then regression testing means there's a change in a service, means the code is being changed, so that regression testing is need to be done. Then web service interoperability. So in this web service interoperability is like open for the industrial organization. So industrial organization what have some interface interoperability interface for the platform. that there's a platform and that has to be interacted well. And then there's a operating system. So fixed set of performance issues are there. Then there's a programming language. So all these things has to be follow some standard to maintain the interoperability between two, three different languages or platform. There has to be interoperable among the different operating system, Ubuntu and Windows. Apple should be able to call these web services. Then different programming language could also be able to call these. C or Java, Python could all be able to call web service. So this is web service interoperability. And web service interoperability basically helps to define some protocol, and they need to have some interoperable exchanges between messages of web service. So this protocol and the message exchanges need to be done. Then SLA, QoS, service maintenance. So what does it means? Scope, quality, and responsibility of a service provider to maintain uh, the consumer's demand. So this is what is service maintenance, and it's demand of maintaining quality of service, and for that you need to monitor a web service continuously. Then change analysis basically enables regression testing, so and help the web service quality of service maintenance, and it ensures that whether that SLA requirement are being fulfilled or not. Then there's intra-operational or inter-operational change analysis that we discussed just in the previous classes, that it helps in the regression testing, and that regression testing helps in to maintain quality of service and service level agreement. Then reduction in the effort of regression testing. What happens, we can, if we reduce the effort required for regression testing, this leads to reduction in the effort of monitoring and maintenance of quality of service. If we lower down the effort for the this QoS, then it will lower down effort to maintain and guarantee the cost for service level agreement. So what happens in construction of composite service? There is various type of service that are being combined together, and this need to be kept satisfactory quality of service. Means if there is four, five different service working together, then this integration should not affect the quality of service. So quality of service should have to be good in case of composite service as well. Then this service provider basically have to update and exchange some services to meet some new requirement. So the SLA violation be should be always SLA violation where an incorrect change leads to some incorrect behavior. So what happens? Sometimes service provider updates or enhances a service. When service provider improves and updates its service, these are because of new requirement. These happens because of new requirement, but some unintentional SLA violation may happen. Why this unintentional SLA violation may happen? Because of incorrect changes, and incorrect behavior will create violation in SLA. Thus, because of all these reasons, you need to keep on monitoring the service, and QoS monitoring is required. And you need to keep on checking and re-establishing some specific QoS in the SLA. Thereafter, you have to modify some SLA as well if these QoS requirements are not being met out. Then there's reduced cost in web service effort. So if we can able to reduce cloud or web service maintenance effort or cost, then it is easy for and to maintain and reduce the effort for guaranteeing quality of service and SLA. Thereafter, regression testing has one goal to maintain QoS and SLA. So regression testing has goal to maintain as QoS or SLA. Then this reduced regression testing can be done with reduced test suite size or easily constructing this regression test suite, how better you can construct this regression test suite, and this will save effort and reduces the cost of maintenance. So whatever we discuss in this slide is been available in these publications and in these links. So thanks all of you. I hope that you enjoyed this part of uh, coursework. Any doubt or any query, or we'll meet in the next class. Okay, so we'll finish up here.